Hi, my name is John Williams, doing a final project for EML 3701, Fluid Mechanics. This is a wind tunnel simulation, and let's get started. Okay, first thing is first, we have a 2D project we're doing here, and we will get into design modeling right away and create our geometry. We'll start on an XY plane here, and we will start by creating some reference lines. One here, one there. Let's dimension these first two. 0.6096, and this one 0.6096. Okay, back to line. Let's make two more lines. Actually, I don't want to do that. Okay, let's dimension these two here. And this one, H3 is going to be 1.1176. And H4 is going to be 1.5478. 5748. 5748. Okay, we will make some vertical lines here. Let's put some constraints on these lines, making midpoints here. Okay, let's dimension these lines. B5. This one is going to be 1.62556. This one is going to be 0.6096. This one will also be 6096. And this guy right here, V8 will be 0.889. Okay, let's go and connect the dots. Everything looks pretty well connected. Okay, let's actually get rid of some of these reference lines here. Okay, looks like we got rid of all the reference lines. Okay, so let's come up here, concept, sketch one, apply, generate. There we go. There's our wind tunnel right there. Okay, let's head back into workbench. Let's go and mesh this thing out. Get rid of this one. There we go. Comes right up. All right, let's generate some mesh right off the bat and see what we've got. All right, let's go to insert method. Boom. Apply. Let's add some triangles in here. Generate. Oh, right, let's go to here. 0.01. Make these 10 millimeters for our element size. And let's generate mesh. This may take a second. Okay. That looks like some decent triangle mesh. All right, let's name our walls here. Where's my edge select? There we go. That back up there. This is going to be our velocity inlet here. And let me see here. This back here. This is my pressure outlet. Okay, and then these all the way around here. These will all be my wind tunnel wall. Okay. All right, let's go back to Workbench. Let's update this mesh. Mesh update, there we go. Let's get rid of that. And let's head into setup. Double precision. I'm going to run 2 solver processes. All right. There we go. There's our wind tunnel right there. See our mesh. Okay, going to models right here. The viscous effects. We're going to go with standard K epsilon, enhanced wall treatments, pressure gradient effects on. Okay, let's go down here to materials, fluid, air. We're going to use standard 1.225 kilograms per meter cubed for density, and our viscosity would be 1.7894 times 10 to the negative fifth kilograms over meters per second, meter seconds. Okay, we want to make sure our surface body fluid is air, and it is. Apply, close, boundary conditions. Okay, we have a velocity inlet. It says velocity inlet. Let's edit this. We're going to do this for 10 meters per second. 10 meters per second. Gauge pressure is at 0. Apply, close. Pressure outlet is that pressure outlet. That's good. Okay, and reference values. We don't need it. Let's see reference values. Yes. Okay, we will be doing this from velocity inlet. Um, let's just do surface body as well. Okay, we don't need any report definitions. Go to initialization. More settings. I'm going to do 30 iterations. Okay, and initialize. And initialization is done. Go to run calculations. Do 150 iterations here. And away we go. Off to the races. Okay, calculations are complete. Okay, so for our assignment, it says we need to get pressure, velocity, total pressure, and dynamic pressure contours. So let's go down here to graphics. Let's look at contours. Okay, so for our static pressure, let's see, we're going to do everything here. I'm going to go banded and let's see what we got. There we go. This is our static pressure here. Um, that doesn't look too bad. We got these little points here where some kind of deflection is going on. All right, let's look at dynamic pressure. Here's dynamic pressure. You can see it's more turbulent in the middle. And let's look at total pressure. All right, higher pressure near the walls where the velocity is very slow. Okay, and now we will look at velocity. Let's come up here, velocity magnitude. Okay, and you can see there near the walls where it is absolutely zero. It's no slip condition there. Okay, there's that. Okay, now we need to create a center line. Let's see here. We're going to go to X, Y plot, contours here, plots, X, Y plot, new surface. We're going to go to line rake and line. So rake, our line is going to be, I got to add these up, 1.995. Let's see. Oh, plus minus 1.9958. So this one's going to be minus 1.9958. And this is going to be 1.9958 right there. And we will name this center line. Okay, create. Okay, and now we will create a vertical line. Line right here. And this one will be at 0. And this will be at 0. But our Y line is going to be negative 3.3048. 0.3048 and positive 0.3048. Create. Okay. Close. All right, so let's look at for our assignment, pressure, velocity, total pressure, dynamic pressure along the center line of the wind tunnel. Okay, here we go. So for the center line, let's look at static pressure. This is along our center line right here. Static pressure. These are our plots. And for our dynamic pressure plot, it's almost the opposite. And then for total pressure, it gets a little crazy. But when we write this file out to Excel, that line should straighten out. So now let's look at velocity along the center line. There we go. Thumbs up. Okay, now let's look at our vertical line right here. Let's cut this off. Vertical line. This is our velocity. Oh, we have to change our plot directions here. One, there we go. Oh, there we go. And you can see our lines, it's at zero. Velocity is at zero at the upper and lower edges of the wind tunnel where we have no slip conditions. Okay, let's go to pressure right here, static pressure along the vertical line. Looks a little crazy. Dynamic pressure, that looks about right. And total pressure. Okay. Okay. Now, if I was to write these to file for Excel, you can write this. I'll just do one example and we will airfoil one files. We'll just go like that. User files. We'll do final project. One airfoil files. Okay. And come into here. User files. One airfoil files. Foil files, final project right here. Open it in Excel. And oh, well, it would normally come right up in here. File format does not match. Yes, there it is. Okay, so here we have our um, vertical line. This is our wall. So I can make a graph here, something like this. We will select data, add, we'll call this at 10 meters per second. And series values. We will start here, get all of those. Okay, this right here. We'll take this all the way back to the top. And then, push that all the way down. Okay. All right. And there is our graph for the most part. I like to do it in this one here. And it's not a perfect graph by any means, but we can go with legend here, 10 meters per second. Okay, so that's pretty much that in a nutshell. Now we're going to get, for our bonus part, we are going to, let's get out of this. We're going to make a airfoil. Closed Fluent, okay. May take a few minutes. Save. Okay, and let's get out of this. Let's go to this right here. Okay, so let's start a new Fluent here. Go into, let's make this 2D right here. Let's go into new design modeler. Okay. So basically I have, I'm going to set up, well, here, let's just go like this. Point coordinates. It's point. Let's bring this airfoil. These are imported imported text or our coordinates for our airfoil that we imported and generate. And here we go. There is our airfoil right there. Now I've already set up I don't want to make the wind tunnel all over again. Essentially, we have this already imported in here with our airfoil inside of the wind tunnel. We've already done. And there it is. Okay, and there's our airfoil inside the wind tunnel. So again, we'll just go right up here, generate some mesh, get that going on in there. We will set up our method, apply, triangles, home, generate. Okay, let's go with mesh. I'm gonna try and do some sizing around here. Go to edge here. And let's see if we can't get in on this edge right here. For some reason, it does not want to. There we go. Apply. Element size. Number of divisions. We're going to go with 150. Like that, right around there. Home. Generate. Okay. And then let's go to mesh here. There we go. Go to 0.01 again. Home. Generate mesh. And we'll wait. Okay, there we go. And our mesh looks really good around the edges here. Okay, so let's name our walls again. Velocity inlet, name our boundaries, I should say. This right here will be pressure outlet. Okay, and then here we go. And those are all wind tunnel walls. Wall, okay, and then right here, this is going to be our airfoil. Airfoil right there. Okay. All right, let's go back to Workbench. Let's update our mesh right here. And let's get rid of this. Let's head into setup. Double precision, 2 processes, start. So for our bonus part, we're going to get velocity and pressure contours in the wind tunnel, and we're going to get drag and lift coefficients of the airfoil. Okay, so go right here into our viscous effects, K epsilon, standard, enhanced wall treatments, pressure gradient effects. Okay, I want to make sure our material fluid there's all PS 1.225. That looks good. And we want to make sure our cell zone conditions are air. They are. And boundary conditions, velocity inlet, edit, 10 meters per second. And apply, close, Our pressure outlet is still that pressure outlet. That looks good. Reference values. We will start at the velocity inlet, compute from. Everything looks good. We want to go to surface body here. Okay. And let's go down to, we want to report definitions here. New force report. We're going to do drag force first. Drag coefficient on the airfoil. Okay, we'll compute that. And then we're going to do another one, new one, force report lift. We get lift coefficient on the airfoil. Okay, there we've got two. Okay, cool. All right, let's go to initialization. Settings. We're going to run 30 iterations. Okay, and initialize. There we go. Run calculation. 150. Okay, calculate. Off to the races. All right, we are done. Let's go to our report definitions. F1, airfoil. This is our lift coefficient. Compute. Okay, here we go. Right here, you can see our lift coefficient for the airfoil, 0.2477. Let's look at our drag coefficient here. Okay, compute. Okay, here's our drag coefficient, 0.0255. That's our drag coefficient. Okay, let's just quick look at our, see what kind of contours we have going on here. And we'll just do a basic, well, let's look at a dynamic pressure one here. And banded. There you go. All right, we're going to do a better contour. Let's get out of this. Let's close Fluent. We are going to go into Solver. And we can get a better look at the airfoil. Oh, okay, yes. Sorry. All right, results. There we go. Okay. Now, let's go to contours here. Contour one. That looked good. Contour one, this is going to be our pressure. Okay, location, we're going to go with symmetry one here. Global. Let's go with 100 contours and apply. Okay, this is our pressure contour here. Get right up close to it. You can see the majority of the pressure is right at the front of the airfoil. Right there. Okay, let's look at contour two. Well, let's just look at velocity once. Cancel this. Let's just look at velocity, see what our velocity looks like. All right. Here's our velocity of 10 meters per second. And you can see at our walls, we have no slip condition, our velocity is 0. And around our airfoil, right there, it's at 0. All right, so that's pretty much our final project for fluid mechanics. Thank you. Have a great day.